polynomial. What is polynomial? An algebraic expressions of the form a naught a1 ax plus a2 x square a n x square, where is called polynomial. It is generally denoted by px qx, real polynomial. Let a naught a1 a2 an be real numbers and x is a real variables. Then fx is called real polynomial of real variable x with coefficients. Next is complex polynomial. Degree of a polynomial. So some important deductions. Linear polynomial. A polynomial of degree 1 is known as linear polynomial. Quadratic polynomial. A polynomial of second degree is known as quadratic polynomial. Cube polynomial. A polynomial of degree 3. Biquadratic. A polynomial of degree 4. Polynomial equation. If fx is a polynomial, real or complex, then fx is equal to 0 is called a polynomial equation. Quadratic equation. A quadratic polynomial fx when equated to 0 is called quadratic equation. A quadratic polynomial when equations equated to 0 is called quadratic equations. Ax square plus bx plus c is equal to 0. Root of a quadratic equations. The value of variables x which satisfy the quadratic equation is called root of quadratic equations. The value of variable x which satisfies the quadratic equations is called root of quadratic equations. Now, solutions of quadratic equations. Solutions of quadratic equations. Factorizations method. Factorization method. Let ax square plus bx plus c is equal to a x minus alpha x minus beta is equal to 0. Then x is equal to alpha and x is equal to beta will satisfy the given equations. Direct formula. Quadratic equation ax square plus bx plus c is equal to 0, where a is not equal to 0, has two roots. Okay, there are two roots. Alpha is equal to minus b plus under root b square minus 4ac upon 2a. Beta is equal to minus b minus under root b square minus 4ac 2a. Alpha is equal to minus b plus under root d upon 2a. Beta is equal to minus b minus under root 2a, where d is equal to nature of roots. Let quadratic equations be ax square plus bx plus c is equal to 0, whose discriminant is d. Relation between roots and coefficients. Some important relations between roots and coefficients. Quadratic equations. If roots of quadratic equation ax plus bx plus c is equal to 0 are alpha and beta, then sum of roots. So sum of roots is equal to s alpha plus beta is equal to minus b upon a, means coefficients of x upon coefficients of x square. Product of roots is equal to p alpha dot b is equal to c upon a, coefficient constant terms upon coefficients of x square. Also a minus b is equal to under root d upon a. Cubic equation. If alpha, beta and gamma are the root of cubic equation ax cube plus bx cube plus cx plus d is equal to 0, then summations alpha is equal to alpha plus beta plus gamma is equal to minus b upon a, where alpha beta is equal to alpha beta plus beta alpha plus gamma alpha is equal to c upon a. Alpha beta gamma is equal to 1 d upon a. Biquadratic equations. So these are biquadratic equations s1, s2, s3, s3, s4. Sequence and series. Sequence is a function whose domain is the set of natural numbers. Sequence is a function whose domain is the set of natural numbers or some subset of the type 1, 2, 3, k. We represent the image 1, 2, 3, 4, and a sequence containing a finite number of terms is called finite sequence. A sequence containing a infinite number of terms is called infinite sequence. A sequence whose range is a subset of real number r is called real sequence. Progression. A sequence whose terms follow a certain pattern. A sequence whose terms follow a certain pattern is called progression. Series. If a1, a2, a3, an is a sequence, then the sum expressed as a1, a2, a3 plus an is called a series. इसे हम series कहेंगे. A series having finite number of terms, finite series. A series having infinite number of terms, infinite series. AP stands for arithmetic progression. Arithmetic progression. A sequence in which terms increase or decrease regularly by a fixed number. A sequence in which terms increase or decrease regularly by a fixed number. The fixed number is called the common difference of AP. Nth term of an AP. If A is the first term, D is the common preference, and L is the last term of an AP. The given AP is A. Properties of arithmetic progression. If a constant is added or subtracted from each other of an AP, then the resulting sequence is also an AP with some common difference. If each term of an AP is multiplied or divided by a non-zero constant k, then the resulting sequence is also an AP with common difference. If an plus 1, an plus 2 are the three consecutive terms of AP, then if a sequence is an AP, then its nth term is a linear expression selections term in an AP. Any three terms in AP can be taken as any four term in AP can be taken as any five terms of AP can be taken as sum of first n terms of an AP. Sum of first n term of AP. Sum of first n terms of AP is given by Sn is equal to n upon 2, 2a plus n minus 1 t is equal to n upon 2 a plus l, where l is last term. Arithmetic mean. If a are in AP, then a is called arithmetic mean of a, and b it is given by a is equal to a plus b upon 2. If a1, a2, a3, an are n numbers, then their am is given by geometric progressions. GP. A sequence in which the ratio of any terms except first term to its just preceding term is constant throughout. The constant ratio is called common ratio. Nth term of GP. Nth term of GP from the beginning is given by an is equal to ar n minus 1. Nth term of GP from the end is given by properties of general progressions. If all the terms of GP are multiplied or divided by same non-zero constant, then the resulting sequence is also a GP with the same common ratio. The reciprocal of terms of a GP also forms a GP. Exponential series. The sum of the series 1 plus 1 upon 2, 1 upon 3, 1 upon 4 is denoted by the number e. This is exponential series. Exponential series. E lies between 2 and 3. E lies in irrational numbers. Some important series.